looking for rational solutions to this equation, not surprising. Numbers like 3 over 11. Q is the symbol for rational or fractional numbers. So 3 over 11 is an example of a proper rational number. So-called improper might be, 21 over 4. Okay, so again, that's what we mean by Q. And of course, it's no surprise that that's what you could just say find X, remember real numbers, here without too much ado. But in any event, I find it easier just to do the algebra and then substitute the numbers back in. Okay, so notice that in this scenario, we do have a sequence of 3 consecutive natural numbers factorialed. And so n minus 2, n minus 1, and n. So right here, we'll go ahead and note that n is equal to 13. Okay, so n is certainly equal to 13. And again, I think it's easier this way. I really do. Let me know if you think differently, but it's just easier. The numbers get too big, and so you're better off, in my humble opinion, to just do the algebra, okay? Now, and a nice observation is that n factorial is the least common denominator. Notice that n minus 1 factorial is a factor of n factorial. That would be n minus 1 factorial times n is n factorial, and similarly for n minus 2 factorial. So the least common denominator is n factorial. And I've already done most of the work here. What we do is we rewrite the expression we're trying to evaluate, and we just find common denominators. So here, to get n minus 2 factorial to be n factorial, you have to multiply through by this cleverly disguised version of 1 here. Okay, and that's just something over itself. As long as n is not equal to 1, you're not, or 0, you don't have any problems here. In a similar fashion, we multiply through by another cleverly disguised version of 1, n over n. Okay, and in that fashion, we achieve the common denominator that you see here on the next line right here, on the next line right there. And so nice things happen here. The n's cancel, and we end up with this fairly nice looking expression, not too many terms. And so again, the original problem is equal to the reciprocal of x. And so we can just invert right here, reciprocate if you want to call it that. Now remember that n was equal to 3. Excuse me, n was equal to 13. N was equal to 13 at the beginning of the problem. Remember right up here, let's see. Yeah, n equals 13 was the value of n for this particular setup. Okay, and so what does that mean right here? That means that this piece right here, let's see here, we would get n factorial, so it's 13 factorial. Over, now folks, 13 squared plus 1. Okay, so this is equal to 13 factorial over 170. It's going to be a huge number. 169.1 is 170. All right, and so I guess if this is a math competition, you just leave the answer this way. But if we must simplify it, this would be what? We're going to need some space here. So you're going to have 13 factorial over 1. I'll just do this. Let's see. That would be 2 times 5 times 17, right? So we'll get a little bit of simplification here, but it's still going to be kind of a messy problem, right? 2 times 5 times 17 is the prime factorization of 170, right? And so this would equal to, we can leave out the 1 and the 2, so we'll have 2 times 3. Or no, wait a minute, yeah, the 2's go away, right? So, sorry, let me erase that. Okay, so we'll end up with what are we going to have here? So the 2's go away, the 1 goes away, and so we're going to have 3. All right, 3 times 4. 5 gets canceled, right? 3 times 4, skip the 5, and then we have 6 times 7 times 8 times 9 times 10, all the way out to 13. Let me extend this, folks. Okay, all over 17. Okay, and of course this is this part. Again, I don't know in a math competition. I don't know how much they would expect you if they don't want you to waste time to multiply this out. But if you do multiply this out, 3 times 4 times 6. Again, all this stuff canceled out. You end up with 622 million. 622 million. We'll go ahead and delineate with the commas here. 622,702,080. Okay, I know you guys are all dying to see this number. Again, I think in a math competition, you know, you would be allowed just to stop and not waste precious minutes on the laborious calculation. Okay, and then all divided by 17. Okay. All divided by 17. And folks, this is definitely a proud member of the set Q, right? Remember we talked about that earlier. Probably unnecessary, okay. I guess that's how we do it. Okay, so y'all, that is the answer.